Okay, so I will also be teaching these in class. So if this video is not enough to make it make sense, I will be having class of this too. But especially for the singers who aren't going to be here, this just seemed to make the most sense. So we have kind of 4 topics ish. Ish is more like 3 topics that are part of the curriculum of the course, but aren't necessarily tested. And so we moved the final up to accommodate the singers, and then putting the bonus coverage at the end. That also allows you guys to have time closer to when you actually learn the content. So that's why we're kind of doing things this way. All right, so what we have here, today, the first topic we're going to talk about is Newton's method, which is a method for approximating the zeros of a function using tangent lines. So the basic idea is, every time we do what's called an iteration of Newton's method, we get a new, we find this tangent line, and then we find this tangent line, and I go to that new x, and then I find the tangent line by that new x, and as I look at each of these lines, so if I look at the tangent line, say here, this x-intercept becomes my next place I find my tangent line. And then this x-intercept is the next place. And as I get closer and closer, as I do each iteration, you'll notice that the x-intercept of the tangent line is getting closer and closer to the actual x-intercept of my function f. So as we look at, say, this is a generic tangent line, okay, we know that the slope of the tangent line is f prime of x1, and it goes through the point x1, f of x1. So to find the equation, if I do y minus y1, now that's y minus f of x1 equals my slope is f prime of x1 times x minus x1. And so that's always the equation of a tangent line at some point some value, in this case x1, okay? And then if I want to find where does that tangent line equal 0, I'd replace the y with a 0. So I'd get y minus f of x1 and since this is 0 minus, I'm going to get rid of the 0. So essentially, I'm solving this because that 0 is kind of it doesn't really matter, okay? And because 0 minus f of x1 is negative f of x1, okay? So with a little bit of algebra to rearrange this, I can find that the x value, which I'm going to call x2, okay? Because x2 is where that tangent line crosses the x-axis, is equal to x1. And again, this is just me solving for this x, okay? To x1 minus f of x1 over f prime of x1. So now if I want to get closer, if I want to say, okay, so now I find this one, and now I'm trying to find where this line equals 0, now x2 becomes x3, x1 becomes x2. And so we can do this repetitive process to kind of get us to a new equation each time. Okay, so here's let's go through, and here's the general form of that. And how I might ask you the question is I'll tell you how many iterations to do to get to your estimate of the 0, okay? So as I look at this, if I have f of x, so I have f of x equals x squared minus 2. So f of x1 would be f of 1, which would be 1 minus 2, 1 squared minus 2, so negative 1. And then we would take our derivative, which is 2x. So f prime of x1 is f prime of 1.
Good morning. Today is Monday, December.
Okay, so then f prime of x1, which is 1, would be 2 times 1, which is 2. Okay, so here's the crux of Newton's method. So I'm going to find x2, and x2 is going to equal x1 minus f of x1 over f prime of x1. So it's always kind of doing the same basic structure. So to find that x2, in this case, I would do 1 minus negative 1 over 2 and get 1.5. So now if I want to find x3, I'm going to do 1.5 minus, all right, so now I need to figure out, well, what is f of 1.5? Which is, we would do 1.5 squared minus 2, which is 0.25. F prime of 1.5 would be 3. All right, so now I do 1.5 minus 0.25 over 3. And that works out to be, if you just throw that into a calculator, 1.4167. Okay, so that is if I'm doing 3 iterations, this is my approximation for when this function equals 0. Well, let's look at where does this function equal 0? So I've got x squared minus 2. 0, so then I've got 2 equals x squared. If I take the square root of both sides, I get 1.414, which is pretty darn close to that 1.467. So again, just an example of Newton's method. Let's go through another example real quick. Okay, so so as we're looking for this next function, the first thing we want to do is, all right, so we have our f of x equals e to the x plus x. And let's go ahead and take our derivative because we're going to need to use that quite a bit. And we'll get e to the x plus 1. Okay, and so then, like, we're trying to approximate a 0 of e to the x plus 1. One of the things that'll be helpful is, like, where do we start? So in this particular case, I want to pick a function, like, the whole point is we're trying to use as easy of numbers as possible. So as I look at this function, when x equals 0, I have e to the 0 plus 0. That's a pretty easy place for me to start because I have f of 0 equals 1. Okay, so I'm going to let my x1 equal 0. So to find x2, I would do 0 minus. All right, so f of 0 would be e to the 0 plus 0 on top, and e to the 0 plus 1 on the bottom. So as I'm looking at that, so as I kind of go through and look at that, I essentially have 0 minus 1 over 2. So my x2 is negative 1/2, or I'm going to use negative 0.5 moving forward. Okay, so that means x3 is going to be negative 0.5 minus e to the negative 0.5 minus 0.5, because that's f of negative 0.5, and then f prime of that will be e to the negative 0.5 plus 1. Okay, throwing that into my calculator, I found that to be negative 0.5663. Okay, so now if I do the same thing, I'm going to do it one more time. I would have negative 0.5663 minus e to the negative 0.5663, and I'm just plugging this in. And when I do that, I find it to be negative 0.567, which is very darn close if you just solve for where this equals 0 using the graphing on your calculator. You find it to be negative 0.5671. We're pretty darn close. So Newton's method is a good way for approximating zeros. However, like now technology is kind of the reason Newton's method is no longer part of the tested curriculum is Newton's method is really great for approximating zeros if you don't have a calculator, but even then with the more complicated functions, you wish you had a calculator anyway. So it's this is why it's not really tested anymore. Graphing technology has kind of made it not as important, but it's certainly something to work through. So hold your breath, and I will give you your next video in a second.